Hello and good day. So this is the solution for the quiz under the velocity analysis. So I have here, this is the given, the given of the problem. So we have the point of contact to A. So this is the distance, the list of distance, and this is the figure. So point of contact to A, ang pasabot niya sa point of contact is the point of contact of this wheel. Okay? So we have two wheel, 2 and 4. So therefore, ang pasabot niya sa point of contact is this contact with the ground. Okay? Or contact with this frame here. Okay? So the distance though of point of contact to A, which is here to here, is 0.75 inch. So I just draw this as the space diagram. I did not change the dimension because it is efficient naman to use in terms of transferring it in a paper. So I just use 0.75 here. And A, the distance of A to B is 1.5 inch. Okay, here. Then between two contact points, which is O2, I now designate na ko siya as O2 and O4, is 1.5. Okay, 1.5 inch. And the distance of point of contact to B, which is here, 0.04 to B, is 0.75. Then A to C is 1.2 inch. Then the effective crank angle here, let's consider this, it is 77 degrees. Actually, this angle is used in identifying the direction of the element. But the problem only asked to determine the angular velocity and the linear velocity, but so no need to no need to calculate the direction of the each element here. But there are problems that you're required to calculate the direction, then you will utilize the use of this. But for the meantime, the use of this effective crank angle and the angle between the BAC, it is needed to transfer the figure into your space diagram. Okay, so we have a effective crank angle which is 77 and the angle BAC which is 30 degree. Okay, then the angular velocity of this wheel is 15 rad per second. Okay, now we are asked to identify the angular velocity of these three, this element here, and the angular velocity of 4, which is the second wheel. And also, we need to identify the velocity of A, velocity of B, and velocity of C. So, these 3 points here. Okay, so first step is we need to transfer it in a space diagram. Using this figure, using the given data, we need to transfer it in a space diagram. Now, this is this space diagram. Okay, in the space diagram, as I mentioned earlier, that I utilize the given na lang. So, I did not use a scale. Diba? Sa atong previous nga discussion, we use a scale in transferring the katong given into a space diagram. But for this case, the distance given is very efficient to use, no? So in transferring the or drawing the space diagram. So this is now the space diagram. So as you can see from the figure, it's a wheel lang, no? It's a wheel. But if we will analyze it deeper, we can say it is a 4-bar mechanism. It's a 4-bar chain, okay? With point A and point B here. So if we will connect that, so ang i-analyze lang nato is this point na lang. So we will consider this as a 4-bar chain, okay? So it is easy for us to calculate na lang. Now, let's utilize the given. Now, the problem gives us this angular velocity of A. We know that the relationship of angular velocity and linear velocity is just equal to V equals to R, which is the link multiplied by the angular velocity. So this is the relationship between the linear and the angular. So we will utilize this since given ang W2, this angular velocity, it is the angular velocity of A because A is located with this wheel. Diba? So kung unsa ning angular velocity sa A, it is equal to W2. Okay? So therefore, we will convert this W2, this given W2, into a linear motion, a linear velocity. Okay, using this formula that the velocity at A, at point A, because point A is absolute. Okay, so point A is equal to the link R, which is the distance from A to O2, multiplied by W2, which is the angular velocity at this wheel. Okay, so therefore by just a simple mathematical plug and play lang, then 0.75, which is the distance from A to O2, here given here, so therefore multiplied by 15 rad per second, therefore the velocity of point A is 11.25 inch per second. Now, this is your given now. So if nanatay siya ka-given, then we can draw the space diagram, right? So in drawing the space diagram, we will use a scale for this time. So let's say for example it is 11.25, then I will use a scale of, in 1 inch there is 5 inch per second. So this is now my scale. In 1 inch equal to 5 inch per second. So what will happen to VA? So in the velocity diagram, the equivalent of VA is just equal to 11.25 divided by 5, which is 2.25 inch. Okay? So this is now the value. So this is the equivalent value of velocity A in the velocity diagram. Now, after that, we need to locate the fixed point for instant time. For example, here, if we will consider this figure, the fixed point is this O2, although this is not a fixed point, this is not in reality, this is the fixed point because it's rotating. No? Ang i-consider lang nato na siya, but at point of contact lang, we consider as the fixed point. So fix ang atong fix ang atong kibali ato siyang gi-treat as a fix nga machine element. Okay? So O2 and O4 is the fix. So we'll start here by locating this. Then the given is we have VA. Recall that the direction of VA is always perpendicular to link AO2, which is here. Kanina link class. So what we need to do, because A is connected to O2, which is this is the O2 and O4, then we will create a perpendicular line from this point O2. Okay? So create a perpendicular line. Ang measurement niya is 2.25. Okay? So 2.25 inch. Under ang iyang distance ani 2.25. The point 0.02 to here. This is 2.25 inch. Now, the next thing to do is to what do you call that? Locate the direction or draw the direction of velocity A, velocity BA and velocity B. Because in order to calculate the velocity B here, it is just equal to velocity A plus the velocity of B relative to A. Recall in your physics, right? That in drawing a triangle, a vector triangle, we can say that the velocity of B, it is simply equal to the velocity at A plus velocity of B relative to A. So therefore, we need to draw or need to locate where is this V, velocity of B and velocity of B relative to A. Okay, now, let's start with velocity B relative to A. Okay, so by looking at the figure here, so B is connected to A. So therefore, we will start by drawing at the tip of A so that we can locate B. So this is why I draw this line, this perpendicular line. Okay, now recall that it is always perpendicular to link AB, which is kani. So therefore, perpendicular niya is, kung we will draw that, this is the perpendicular line of this. Okay, so this is the perpendicular line of this link. Okay, so draw. So this is now the direction. I put dito na. This is now the direction of velocity BA. This vertical line here. Okay, so the next thing to do is to locate this velocity B. We know by looking at this figure, velocity B is connected with point 0.04 because it's an absolute. It is an absolute velocity with respect to 0.04. Okay, so therefore we need to create a line which is perpendicular to this link that is connected to O4. Pero asang O4? This is now the O4. Okay, so this is O4. Then we will create a perpendicular line. Ano niya? Siguro perpendicular line is aka. This is your kuan. Then you will draw like this. Okay, so this is now the perpendicular line. As you can see, the point of intersection, it is the location of B, di ba? So the location of B here, point B, is the intersection of the velocity BA and the velocity VB. Okay, the intersection between the line of BB and between the direction the location of point B is the intersection of line VBA and line VB. Okay, now by looking at this figure, so this is now the figure or a velocity diagram. The point of intersection is here, but we cannot measure the velocity BA. So therefore, by simply looking at this, it is an infinity. So therefore, VBA is 0. Diba? Wala tayong ma-measure. Because ang ato lang hibalan is mo ni ang iyang line. Diri siya malocate. But in terms of intersection, because this is point here measuring to point B, taman dira ang point B. Kay diri man this is the kaniman ang line sa atong velocity B relative to A, kani nga point. So therefore, velocity B V relative to A is 0. So what will happen to the equation? So kung i-plug in nato ang 0, what will happen? So therefore, velocity of B is just equal to the velocity of A, which is equal to 11.25 inch per second. Diba? So if this is the line of action, tapos 0 siya, okay, it is in infinity man. So kanilang ilang point of intersection, but if we will measure that using a ruler or by simply looking at that, no, it is equal to VA, 'di ba? From point here to point here, it's equal to VA. Okay? Then using this value here, we can calculate now the angular velocity using the formula nga kanina sad. The same ato niagi, which is V equals to RW, but we will replace that by its true value. Okay, so W3 is VBA over RBA, which is equal to 0 because 0 ang BBA. Then the angular velocity of W4 is equal to, which is kanyang 4, it is VB over the link of B going to O4, which is 0.75. Here, 0.75. So 11.25 divided by 0.75, it is 15 rad per second. So as you can see, the angular velocity of these 2 and 4 is equal, no? So as if you can remember, it is the inversion of the 4-bar chain, which is a two-wheel action, no? Katong number 2 ata to, number 2 na inversion sa kuan. Okay? Then the next is we need to calculate the velocity at C. Okay? So if this is point C here, by simply reviewing or recall that to calculate the velocity of C, it is just equal to the velocity of A plus the velocity of C relative to A. Diba? Kani, if this point A ay point C, then connected siya to point A. So we will draw a perpendicular line. So a perpendicular line niya na is nakana. So if we will draw that, this is the line of action, or not the line of action, this is the line of direction of velocity VA. Okay? So as you can see again diha, it is infinity na sad ang velocity VCA. So what will happen? If this is 0, therefore velocity of C is just equal to velocity A, which is equal to 11.25 inch per second. Okay? So this is how you solve for a velocity analysis using the graphical method. So using this value here, class, I already give you the answer, which is the answer is here, 11.25. It's almost no? Then if you will draw that if you will solve this problem using the instantaneous center of velocity, makita nato na this is an infinity here, going infinity, going infinity. Recall the second case of ano, using sa instantaneous center of velocity. Case number 2, if you have two object, what will happen if the two points is in infinity? So wala siya intersection. So what will happen? So review that and solve this problem so that you can understand the concept of the velocity analysis using the ICV. So that's all, and thank you.